So this is a video, and we are going to talk about using trigonometric ratios and trigonometry to find missing sides of triangles. So the beginning part we're talking about are ratios, and you should have gotten out of the last lesson that there is a relationship between the sides and angles of a triangle. And so if you are looking for the sine, you are looking for the opposite side over the hypotenuse. If you are looking for the cosine of an angle, you're going to take the adjacent side over the hypotenuse. And if you're looking for the tangent, you're going to take the opposite side over the adjacent side. And for any right triangle, well, that's really irksome. Let's hope that just stays up there, which it's not doing. That's kind of annoying. So for any triangle, if it's a right triangle, you can use SOH, TOA, or sine, cosine, and tangent. So if we take a look at this angle, we're talking about angle A. So that's this angle right here. And then we want to make sure we know which parts are which. So when you have an angle, and if you were actually to stick your finger on this, which you can because you guys don't have touch screens, you touch two different sides. You touch the adjacent side and you touch the hypotenuse. So the hypotenuse has to always be across from your 90 degrees. And then the one side that you don't touch is called your opposite side. So if we're looking for the sine of angle A, sine is opposite over hypotenuse. And so we want the opposite side, that's 6, over the hypotenuse, and that's 10. And then because we can reduce this, we would say divide by 2, we get 3 over 5. And that would be our sine ratio. For cosine, cosine is adjacent over hypotenuse. So the adjacent side is 8. The hypotenuse is still 10. And 8 over 10 would be our ratio. Since we can, we're going to divide both by 2. And we're going to get 4/5 as a reduced fraction. Tangent is the opposite side over the adjacent side. The opposite side is 6. The adjacent side is 8. And again, we can divide both by 2. That would be the equivalent of 3/4. For our second example, this time we're going to use the diagram and we're going to find sine of B, cos of B, and tan of B. So now you have to be super careful because now we're talking about angle B. And so if this is our angle, think of sticking your finger right on there. Let's put the hypotenuse always across from 90. So hype is here. Now, if you stick your finger on B, the one you're touching that's not the hype, that's now your adjacent side. And then your opposite is the one that you don't touch. So label them first. It really makes a difference. Sine is going to be opposite over hypotenuse. So for angle B, the opposite side is 8. The hypotenuse is still 10. And again, we can divide top numerator and denominator by 2, and we're going to get 4/5. I don't know why that little box was there. Cosine is our adjacent side over our hypotenuse. And adjacent side for angle B is 6, and the hypotenuse is 10. Divide both by 2, that's going to give us 3/5. And tangent is going to be opposite over adjacent. And so the opposite side for angle B is 8, and the adjacent side is 6. And since they're both even, we're also going to divide by 2. So 3/3 will be our final answer. All right, so I'm going to have you stop there. So stop here. And I want you to go and find the practice problems. That'll let you do a little practice on this before we go any further. Okay?